Okay, as we continue from our previous lecture, we were describing the trends, what happens to the elements as we go down the group. Yes, we had talked about the atomic and ionic radius, and we had also talked about the strength of the bonds. Now we want to discuss the ionization, what happens to the ionization energy as we go down the group. So basically what happens is that it decreases. But we want to see why the ionization energy decreases. For us to be able to know why, we have to first describe, or we have to first define what is ionization energy. Ionization energy is the heat energy that is required to remove one more of electrons from one more of separate gaseous atoms or ions. The heat energy that is required to remove one more of electrons from one more of separate gaseous atom or ion. Yes, so in order for us to be able to know why the ionization energy is decreasing, we have to first know what is happening to these factors as we are going down the group. We have already talked about the size of the atom, whereby we were saying that the size of the atom, they are going to increase as we are going down the atom. Why are they increasing? The number of electrons as we are going down the group, they are increasing. And when the number of electrons increases, it means that the shells, they are also going to what? They are also going to increase. And when the shells does increase, it means automatically the size of atom has got what? Has increased. So when the size of atom has increased, it means, okay, just look. We've got the nucleus, we've got one shell, we've got two shells, right? This is the first, this is atom A, and then we've got this one, nucleus, second shell, third shell, fourth shell, and then we have got an electron here, and we have got an electron here. Now, the nucleus, this nucleus here, it is the one that is pulling these electrons towards itself. The electron is saying, no, I don't want to come there. The electron wants to go to the opposite direction, but the nucleus is saying, come my brother, we are inseparable. So there is a force of attraction between this electron and the nucleus. But now look now. The distance or the atomic radius between this electron and the nucleus is small compared to the atomic radius between this electron and this atom. What does it imply? This is going to imply that the force of attraction between this nucleus and this electron is greater compared to the force of attraction between this nucleus and this electron because of the difference in the atomic radius. The greater the atomic radius, the lesser the force of attraction. It is far away. This is the same example as why long distance relationships don't work. You are simply far away. So we are saying that the smaller the atomic radius, it means the greater the force of attraction. What does it imply when we are talking about the ionization energy? We are saying that since atom A and atom B, since atom A offers more force of attraction, it means there is the requirement of a large amount of ionization energy to be able to remove this electron from this atom A. And also, when we are talking about the atom B, it means that the amount of energy that is required to remove this electron from this atom is going to be less compared to the amount of energy that is required to remove this electron. Why? Simply because of the difference in the atomic radii. I don't know if you are getting me, but I hope so. the difference in the atomic radius is the one that is resulting in us having, this one is going to be having more ionization energy, this one is going to be having less ionization energy because of the difference in the size of the atom. Okay, moving forward, we are going to talk about the shielding what? The shielding effect. The shielding effect. First, we are to define what is shielding effect. Shielding effect is the repulsive force which inner shell electrons, supposedly we've got electrons here, electrons here, electrons here. These inner shell electrons are exerting on the valence shell. This is the ones that is referred to as the valence. When we are saying valence, we are just simply saying outer shell electrons. Outer shell electrons. So the inner electrons, the repulsive force which they exert on this electron is what is known as the shielding or screening effect. Yes. So, as we are going down the group, it means the number of electrons, they are going to increase. And when the number of electrons has increased, it means there is going to be an increase in the repulsive force, which these inner electrons are going to be exerting on the valence shell electrons. And when that happens, it means the ionization energy is going to decrease. Simply, we are now requiring less energy to remove this one. Because like we are already trying to knock it out of the what? Out of the orbit. So generally, we are going to require what? Less ionization energy. So we are saying that in conclusion, ionization energy as we are going down, it decreases because of the increase in the size of the atom and increase in the what? In the shielding effect. I thank you. Thank you so much.